Hey Womps, today we're going to go over how to solve linear and quadratic equations. And this is something that we've been working on and have used throughout the entire year. It's information that you've seen before, and we're just going to take this first part of this week's lesson just to review how to do this and the steps that we talked about this year. So in general, your steps are right up here, numbered 1, 2, and 3. We're going to start off by distributing and combining some like terms where you can. If you notice that there's only one term with an X when you're done, try to use that SAD map, that PEMDAS backwards mnemonic device to try to help you figure out what should be moving away from the X and which one you're going to move next, and move all those things to the other side. If you see more than one X in there, that probably means you're going to have to do some factoring or some quadratic formula to be able to solve and come up with the final answers. In general, we're looking for X to be equal to some sort of number when all is said and done. So we do want X equals. We want to try to get X by itself in these equations. It is possible that you might have more than one answer. That is entirely possible when you solve these. So we're going to run through two. We're going to run through one linear example and one quadratic example. So your first step you want to do is to distribute and combine your like terms. So in this first example, we're going to distribute the 6 over here. I'm going to end up with 3x plus 5. 6x minus 12. And we want to combine all the like terms together. So what I'm going to do is I'm going to move the 6x over to the other side by subtracting it. And I'm going to subtract the 5 and move the 5 to the other side by subtracting that as well. So I'm going to end up with a total of negative 3x is equal to negative 17. So now that all my like terms are combined, I'm going to decide what my strategy is going to be next. I'm looking and I see only one term with an X in this equation. There's only one X in there, so we're going to get that X to be by itself. To do that, I'm going to just divide by the coefficient. And we're going to end up with a fraction for an answer of 17/3. For my other example, there's nothing to distribute, but I do have some like terms to combine. I'm going to subtract the 3 to move that over on the same side with everything else. We're going to end up with 2x squared plus 8x minus 10 is equal to 0. Note that there's two terms in here with x. We have the x squared term and then the 8x term. Those are not like terms. I can't put them together, so that means that I have to try to solve this using either some factoring, or you can use the quadratic formula. So if you know quadratic formula and you like it, you can use it at this point. I'm going to try to use some factoring and remind you of your factoring for what happens with this one. So first of all, every single one of these terms is divisible by 2. That means there's a greatest common factor of 2. So everything divides by 2. And then it's a PS2 factoring afterwards. We're going to multiply to get negative 5. We're going to add up to be the 4. And the two numbers that are going to do that would be a positive 5 and a negative 1. So again, depending on how you like to do this, if you like to do this with the grouping or the reverse box method, one thing I want to point out to you is the 2 that we took out over here, it doesn't have any effect on how you do the PS2. So if you like to do the reverse box way, you would set this up as x squared, a 5x, negative x, and a negative 5. And you'd look at each row and each column to figure out what has to be on the outside. X and x has to be outside the first box. At the end of the top row, we have to have a 5. In the bottom row, it looks like we have to have a negative 1. So overall, it looks like we have a 2, x plus 5, and x minus 1 for our factoring. And again, you can do that grouping strategy if you prefer that way. So we've got the 2, the x plus 5, x minus 1, all equal to 0. Each one of these makes its own equation. 2 is equal to 0, x plus 5 is equal to 0, x minus 1 is equal to 0. Now, 2 being equal to 0 does not make any sense. That's not going to be an answer for us. So it's just not equal to 0. There's no answers there. X plus 5 equal to 0 is something we can keep solving. We're going to subtract the 5. We get an answer of negative 5. X minus 1 equals 0 is also something we can solve. We're going to add the 1 over. X will be equal to positive 1. So this equation has two different answers. Our answers would be -5 and +1.